All right, this video I want to talk about two very important generating functions. One is called moment generating function. And another one is called, you probably never heard about this, it's the probability generating function. Probability generating function. So moment generating function, just like its name indicates that, it's a function that helps you to generate moment. So it's a function of t, and it's defined, or how do you find this, is expected value of e to the power of tx. And the way to use it is when you take a derivative for this, and if you take a derivative for one time and plug in 0 for t, you will get to the first moment, which is first raw moment, which is expected value of x. And if you plug in derivative, taking a derivative 2 times and plug in 0, you get a second raw moment, and etc. If you do this to taking derivative like n time, then plug in 0, and you will get to the nth moment. So it's a function that helps you to get all kinds of moments. That's actually some of the continuous distribution. In the distribution table, you will see a moments. That's how they find it, because if you have explicitly described the distribution, then if you're mathematically able to calculate its moment generating function, then you can mathematically calculate the general derivative of it, and you can derive a formula for the raw moments. Theoretically, this is a very important concept, but practically, this allows you to calculate all kinds of metrics, which includes mean, variance, skewness, kurtosis, all kinds of things, by using that formula. And this is actually a concept that will be tested in your exam P material. Now, next one is a probability generating function. Just like the name is saying, it's helping you to generate probabilities. But the way to use it is slightly different. So probability generating function, you get like P of t. It's also a function of t. And it's expected value t to the power of x. And the way to use this is when you take a derivative, regardless of however many times. So let's say you take a derivative for n time, and you plug in 0, and this is a part you plug in 0, where the moment generating function here is also your plug in 0, and you taking a factorial, n factorial, you will actually get the probability of n, which is, say, probability 1 is happening, 2 is happening, 3 happening. What is the probability of 1? What is the probability of 2 and 3, etc.? This is actually a case when you plug in 0, and it's very similar to the moment generating function. And there's another special characteristics for this is if you do not plug in 0, you're still taking derivative, but you plug in 1. If you plug in 1, you actually end up with a factorial-like types of expected value. So it's x minus 1. You keep decreasing until x minus n plus 1. So for example, if n equal to 10, this will be x minus 10 plus 1, which will x minus 9. It will be x minus 1, x minus 2, x minus 3, all the way to x minus 9. This will give you another special types of moment. But this is the case, you have to plug in 1. It's a little bit special, it's different. Is the similarity between moment generating function and probability generating function is moment generating function help you to generate moments. These are all considered moments. And probability generating function help you to generate the probability. These are probabilities. Now I'll give you a numerical example. Say you're given p of 1, plug in 1, you get a 2. P taking derivative 2 times, plug in x equal to 6, asking you what is the variance. Now you need to know what is the p, which is representing its probability generating function. Taking derivative 1, that is equal to, picking probability 1, that is equal to, we're going to apply this to this green formula. We're going to apply this to this green formula, and that is equal to expected value of x, because n equal to 1, x minus 1 plus 1 is x, so it's probability expected value of x. Therefore, it's given, which is 2. When you take in derivative x, that is the expected value of x multiply x minus 1 because it's taking derivative twice. So expected value of x squared, expected value of x, and you are already given this is equal to 6. And you also calculated that this is a 2, this is a 2, therefore this is a 2. Therefore, expected value of x squared, you will get 2 plus 6 will be 8. And variance. Variance is equal to expected value of x squared minus expected value whole thing squared. And give another color. This is the second moment, which is 6. What's the color I've been using for second moment? I'll be using purple. Let me try to be more consistent. And I'm going to use purple for this. Second moment. Therefore, you will get 8 minus 2 squared. So for 8 minus 4, so the answer is 4. Let me be a little bit more consistent with my color. I'll be using orange for this. So this is your first moment, 2, or average, and this is your average, this is your average, and this is your second moment, second raw moment, second raw moment. That's how you find variance. It's this kind of question. It's really just testing your knowledge of understanding what is a moment generating function, what is a probability generating function, and these are actually very important theoretically because it helps practitioner, helped people to derive what is probability, what is moment, and whenever you're working with a very sophisticated or complicated distributions, and this will provide you some very nice formula you can plug in to measure those distributions. And there are reasons, and when we are going through this class, we'll show you why we want to learn some very complicated distributions, because a lot of this distribution was created because they fit in the business scenarios very, very well.